In this video I'm going to talk about factoring trinomials of a specific form. Now a trinomial is an expression with three terms in it that can't be combined, of course. So it looks something like this. It'll look like ax squared plus bx plus c. Now today I'm only specifically going to be talking about when a is 1. So that means it's going to look like this. When a is 1, it's going to, then you'll have 1 times x squared, and 1 times x squared can just be written as x squared. So we're going to be talking about more general forms later on, but for now, I think that's going to be in 6.4. But for now, we're only going to talk about this form. So we'll just go ahead and this form. So since factoring is essentially the opposite of distribution, more or less, let's see what happens when you multiply two binomials. Let's look at two very generic binomials. Let's say we have x plus d times x plus e. So we're going to go ahead and multiply these together. There's different ways you can think about this distribution. Often people will use the what's the word I'm looking for? Mnemonic FOIL. First, outers, inners, last. That works just fine. I like to think of it more generically. I like to just think about this term will be multiplied by every term here and added together. So this times this. This times this plus this times this, then plus this times this plus this times this. I like to think of it visually this way. It doesn't really matter which way you want to, as long as your method works. But let's go ahead and multiply this out and see what happens. So we'll have x times x will give us x squared, and then plus x times e, so we'll have plus ex. Then plus d times x plus dx. Then plus d times e, so we'll have plus ed. Let's make it de, make it alphabetical order. We have, now let's think of it this way. This particular, we could actually simplify this a little bit further by combining like terms. That might not seem intuitive right now, but I'm putting this in as generically as I possibly can. Whenever I actually do this, this won't be D, it'll be like 3 or something, and this won't be E, it'll be like 4 or something. So that means we can go ahead and combine these two terms and make it x squared plus E plus D x plus DE. So all I'm doing is I'm combining these two terms. Like if this was 3x plus 4x or something, then this would be 7x, which is 3x plus 4x. You could also think of this as what we did in 6.1. We're factoring out the common term, x. X is a common term to both of these, so we're factoring out x. So let's go ahead and clear that off. Actually, let's clear off everything. So now we have x squared plus e plus d times x plus de. Let's do a slightly more specific example. Let's actually do the example I was talking about before, just so we can see this a little bit more abstractly. So if we have x plus 3 times x plus 4, x plus 3 times x plus 4. So let's go ahead and multiply this together. We'll get x squared plus 4x plus 3x plus 12. So x times x plus x times 4 plus x 3 times x plus 3 times 4, which is 12. So now I can combine these two like terms, just like I did here, and we'll make it x squared plus 7x plus 12. Okay, and the reason why I did that is just so that you could see a little more clearly. a little bit more concretely, I should say, what this means. So if we're factoring x squared plus bx plus c, so if we're factoring this, we want to find the two numbers e and d. So want to find the two numbers e and d such that e plus d equals b and e times d equals c. Okay, I need to make a line break. Okay, so we want to find, so if we have this x squared plus bx plus c, we want to put this in the form x plus d times x plus e. And we want to find two numbers e and d such that e plus d equals the middle number. So when you add these two together, it'll equal b. When you multiply them together, it'll equal c. For example, let's take a look at this one right here. X squared plus 7x plus 12. Let's do this on a new line, and we'll see how this works out, how the example works out the same way. So if we have x squared plus 7x plus 12, and let's put ex in front of it. So x squared plus 7x plus 12. Okay, let's go ahead and write this. We want to find out what let's pretend that we don't know this yet right now. So we want to find out put this in the form x squared plus e plus d x plus dE. So we want to find out what e and d could possibly be. So we want to find e plus d, where that'll equal 7, and d times e, which equals 12. We want to find two numbers where this is true. So we want to think about this. What two numbers, when multiplied together, make 12? Well, it could be 1 and 12, could be 2 and 6, could be 3 and 4. So now we want to say, so d and e based on this multiplication could be 1 and 12, could be 2 and 6, or 3 and 4, but can they be added to make 7? So let's take a look at, let's leave off the 1 and 12, because generally speaking, that's not going to be what you use more often than not. Let's always consider that to be the trivial case, let's call that. Let's save that for last, see if that works. So let's try 2 and 6. So when you multiply them together, they make 12, right? What happens when you add them together? 2 plus 6 equals 8. So that means that 2 and 6 does not work, because when you multiplied them together, you didn't get 7. So let's try 3 and 4. What happens when you add 3 and 4 together? 3 plus 4 equals 7. So we now have a candidate, I guess you might say, a couple of candidates for what this might be. E could be 3 and D could be 4. Of course, it could be the other way around. D could be 3 and E could be 4. But the bottom line is that we now have two things that when you multiply them together make 12, and when you add them together make 7. So let's clear that off and write it up here, 3 and 4, just to get it out of the way. So let's go ahead and let's go ahead and replace that e plus d with 3 plus 4, and that dE with 3 times 4. You don't need to write this out every time, but I just thought it might be useful to see exactly what's going on. So now we have 3 plus 4x. So we can write this out as, you know what, let's just erase that. That's not really a necessary step. It probably makes things more confusing. So we can write this out as x plus 3 times x plus 4. And we can check this. We can check this by distributing this out, and we did that up here. So we have x plus 3 times x plus 4 equals x squared plus 7x plus 12. So that means that we probably got it right. So, but bear in mind that just because you have a trinomial of this form does not mean that you can factor it out this way. And obviously for the problems you'll have in this section, there will be, but later on we're going to encounter trinomials that cannot be factored, and we'll have to have different methods for dealing with it. So in the next video, I will talk about specific things to watch out for, and then for the next video after that, we'll have examples.